Hi and welcome to the third lesson on the kinematics for the year 12, and this time we're going to look at projectile motion, things falling under the effect of gravity. So, as an introduction, if an object's thrown up in the air, you know from your experience that gravity acts upon it and attracts it to the earth. It's something you've looked at in GCSE physics. It's something you're familiar with. If it's going up, gravity slows it down. That should be highlighted, not crossed out. If it's moving downwards, gravity speeds it up. You know that. The force of gravity produces an acceleration. The acceleration is the same regardless of the mass of the object. Okay, we're going to denote it at the Earth's surface by g, and that's usually taken to be 9.8. Some questions will say 10, some questions will say 9.81. Read the questions carefully. Right, we make two assumptions. We're modeling our objects as particles, objects without dimension. Objects without dimension are not affected by air resistance or drag. Okay, we're modeling our particles as being close to the Earth's surface, so we're going to assume that g is constant. Now, if you were going on to do more physics or doing the further maths course, the physics of the laws of gravity fascinating. It is quite literally rocket science eventually. Maybe when we're all back in school, we can have a look at how we can combine looking at centrifugal force and Newton's law of gravitation, which takes us beyond what we're doing here, for doing things like working with astronomical concepts. Anyway, first thing I'd like you to do is find this example in the book, the one that talks about a stone being thrown upwards, velocity of 6 from a platform 1.2 meters above the ground. And this question, and it's going to be a two-part question because the next example uses the same information. Find the velocity of the stone. So velocity here, the velocity of the stone when it hits the ground. And in this case, they want us to use g is 10. Okay, giving your answer to an appropriate degree of accuracy. Well, how do we do this? Same way as we're going to do all SUVAC questions. Diagram, which is the same for all mechanics questions. Now, notice something I've added to the diagram is here. I've decided which direction is positive. That's going to be crucial because velocity, displacement and acceleration are all vector quantities, so the sign is important. Write down what we know, what we want to find, pick the appropriate rule, substitute in and solve. Now in this case, there are two answers to that equation. The equation v squared is 60 has two answers. Right, so the velocity could be 7.75 or minus 7.75, but the speed is 7.75. The velocity in this case is the negative one, the velocity when it comes back to the ground. The question has values to 2 sig fig, 1 sig fig, and 1 or 2, oh, we know it's 1 sig fig because it's not 9.8. So appropriate this time for 2 sig fig and no more. So 2 sig fig here. This is a two-part question. The next example in the book wants us to find these things if we start with the same velocity and from a platform 1.2 meters above the ground. Greatest height, the stone reach, how long it takes to get to that point, and for how long it's falling. So we'll do the first one first. Right, really common question in projectiles ones is find the greatest height. At the greatest height, the particle stops moving momentarily. It doesn't stop accelerating, stops moving. So if we list what we know, we've got this. U is 6, V is 0, A is minus 10. The initial velocity is 6 upwards, the acceleration is downwards. These two things have to have opposite signs if we are going to be correct. V squared is u squared plus 2as, one of the Suvat equations. You don't need to learn them, they're on the formula sheet. And we get a displacement of 1.8 meters above the starting point, but a maximum height of 3 meters above the ground. Time to reach the greatest height. Well, now we know the greatest height, we could use the 1.8, but since that's something we've calculated, better to use these values, quote the rule, solve it. For how long is it falling? Well, falling is only one part of the motion. Falling is going from the top to the bottom. So in this case, we're going to have to use the 3, the 0, and the 10. Now, in this case, because from the top to the bottom is a displacement downwards, u is 0, a is an acceleration downwards, I'm quite happy to call all of those positive. If you want to check what would happen if you made them all negative, by all means do that. Should be the same answer. Pick the appropriate equation. Soak under tap half a square tea bag. T squared is 3/5. There are 2 possible answers. Choose the correct one. So both questions so far have used the same method, haven't they? They've used quote the rules. Work out, say what you've got, what you want to find, quote a rule, find an answer. So this one here, the last example we're going to look at before you try some of the questions, is one where they ask us to generate the rules. They want us to work in general. So we've got an initial velocity of u, and they want us to use g for the acceleration due to gravity. They want to find the time to the highest point, the time that it takes to return to the ground, and the speed, not the velocity when it hits the ground. So what do we do? Notice it's thrown from level ground. This will have significance when we do the year 13 projectiles in terms of level, horizontal ground, in terms of where things land if we move in 2 dimensions, but not here. Anyway, time to the highest point, we're using u as u, at the highest point v is 0, a is minus g. Remember, it's thrown upwards, accelerating downwards. They have to be opposite signs. Quote the rule, rearrange it. The time to the greatest height is u upon g. That's a nice result to know. Time to return to the ground. Well, if you're thinking it takes the same time to go up as come down, you might be right. If we want to prove that, u is u. When it returns to the ground, the displacement will be 0. S is displacement, not the distance travelled. Okay? S is displacement, not distance travelled. It's thrown upwards, accelerates downwards, a is minus g. If you use this equation, and substituting carefully, we get this. Why not check you know why those are the 2 possible answers? And so, and I should have written on this sheet, the time to return to the ground is the second one, 2u upon g. And as some of you might have hoped to see, that is double the first answer. Now the speed when it returns to the ground, we've got when it returns to the ground, the displacement is 0, displacement not distance travelled. U is u, a is minus g. If we solve this, we get 2 different values for v, because v is the velocity, and when the displacement is 0, v is either u at the beginning of the motion or minus u at the end of the motion. Okay, so when it returns to the ground, v is minus u, but since we have been asked for the speed, I should be putting here, I should be writing here, let's see if I can do this neatly, I should be writing the speed is u. but I can't write with the mouse. The speed is u, the same as it left the ground at. Hopefully, as some of you expected. Right, what have we assumed? We've assumed g is constant and that there's no air resistance, there's no drag. Okay, so to summarize that, the book has this result. Notice that that is a result for thrown from ground level. If something's thrown from a platform above the ground, this is not true. Thrown from ground level. Time taken to return to the ground is twice the time taken to reach the highest point, which we've just demonstrated. The speed of the object when it hits the ground is equal to its initial speed, which we've just demonstrated. Right, in conclusion, this is true for all mechanics questions. Read the question carefully, simple diagram, but in projectile questions, decide which direction is positive. Write down which of the SUVAT quantities you have. Check whether it's going to be G, A is 10, 9.8, 9.81, or indeed just G. Be careful with the signs, okay? All these are vector quantities, you need to be careful with the signs, okay? And then write down what you need to know, pick the correct formula, write it down. We're going to get marks for writing the formula down. You don't need to learn them, they're on the formula sheet. Solve the equation, decide on your accuracy, check whether you're asked for speed or velocity, distance travelled or displacement. They are different, okay? Now, I've done all the work so far. Try the questions in 17C, and then next lesson we'll look at the multi-stage ones. Check with your teachers whether they want some work submitted. I'd like to see some. If you've done a particularly good question, could you take a photograph and send it to me, my group? If you're in other groups, don't send me your work. That's it.